All right, now we're going to start with the unit circle. And that's the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. We're going to look at cosine. We're going to look at sine first, might as well. We're going to look at cosine. And sine goes 0 to 1, but it has points that we'd use to get there. So it's not just we're jumping from one point to another. We would graph a whole bunch of points. We'd plug 0 in and we get a value. It'd be 0. We'd plug pi over 2 in, we get 1. Then it goes to 0, and then it goes to negative 1, then it goes back to 0. Well, if you do plot a whole bunch of points, you have 1, 2, 3, 4 corners of the circle. And I know there's no corners of a circle. Let's say there was. There would be the 4 points that are very, very simple with the zeros and ones and negative ones. Not a whole lot of complicated radicals or fractions or anything like that. Here would be negative 2 pi, negative pi. Sine starts at 0 as we go around the unit circle. It goes to 1, then to 0, then to negative 1. So we go 0, 1, 0, negative 1, 0. And then if you plotted all the points, you'd have this nice smooth curve. You wouldn't have straight lines going to these. It'd be nice smooth curves. But you already know this from watching the videos. That's nice. That's what's nice about watching those, right? Should I check the list? See who watched? Should I check it or should I not check it? Probably not. All right, so we're going to graph 2 times sine of x. Well, sine goes up to 1, down to negative 1. Has a period of 2 pi. It repeats itself every 2 pi. Like this would just keep going on exactly the same way forever. As long as we keep going around the circle, it's going to repeat the values. Those will all be the same. Well, I want 2 periods if the instructions don't say otherwise. So I want 1 period to the right, and I want 1 period to the left. This one has been stretched vertically by a factor of 2. So now instead of going up to 1 and down to negative 1, it goes up to 2 and down to negative 2. It's just like your transformations. It's the same stuff. It's been stretched vertically by a factor of 2. This is 2 pi. That would be pi. Negative 2 pi, negative pi. Sine starts at 0, goes up to the highest, midline, lowest, midline. Lowest, midline, highest, midline. You know, it's got to run smoothly into that 0. So there's 1 period to the right and 1 period to the left. That would just be going backwards on the unit circle. Any questions? Make sure you label your x-axes, make sure you label your y-axes, or you're not going to get full credit. So, because you could have the 4 points, but if you don't label them, they don't mean anything. With the 2 pi and all that. All right, so this one has been shrunk vertically by a factor of 1/4 and shrunk horizontally by a factor of 1/2. Shrunk horizontally by a factor of 1/2. But we will draw the graphs all the same unless the instructions say otherwise. And on your homework, there's a few instructions that do. But we'll make the 4th mark the period. And now instead of going up to 2 and down to negative 2, we're going up to 1/4 and down to negative 1/4. And normally sine would go up to 1 and down to negative 1. So if you take a 1/4 of that, well, there you are at a 1/4. But the period is normally 2 pi. And we have shrunk the period by a factor of 1/2. But the easy part is just take this value that's in front of x and you just divide by that value. So the new period is pi. Well, that's half of 2 pi. So it's been shrunk horizontally by a factor of 1/2. So now, rather than messing around with adjusting the graph, just make your 4th one pi. Negative pi. That'd be negative pi over 2, and that's pi over 2. Cosine. Oh, this is cosine now. We go back to the unit circle. Cosine starts at 1, goes to 0, down to -1, down to 0, back to 1. Yeah, it starts at 1, but that really means it starts at its highest point. In this case, it's not 1 anymore. Cosine starts at its highest point, which will be 1/4 on this one. On the normal, if I'm just graphing y equals cosine of x, it's going to start up at 1. It starts at its highest point. Then it goes midline, lowest, midline, highest. So that you can make this nice smooth curve, this nice smooth wave. And then going back the other way, midline, negative, midline, positive. And there's a graph of cosine. But what I want you to realize is that this wave has a wavelength or a period of pi. This one has a wavelength or a period of 2 pi. And even though I drew them exactly the same width, they're not the same width. You guys realize that, right? They're not. The 2 pi is a lot wider. So I want you to graph them the same because it's really easy to graph them if you do that. You just make the 4th mark the period, you got it. But I want you to realize they're not the same length. I think you do. I hope so anyway. All right. 4 sine x over 2. What happens if what's on the inside is a fraction now? It doesn't really, it's pretty simple, I think, as long as you're getting the concepts here. Make that 4, make that -4. The amplitude is 4. So we have stretched vertically by a factor of 4. The period is 2 pi divided by 1/2. You can just always divide because it's reciprocal. This has been stretched horizontally by a factor of 2. Well, this is a complex fraction. What are you going to do? You're going to end up multiplying by 2. The new period is 4 pi, and of course this wave is much wider than 2 pi, even though we're going to draw it exactly the same. 1, 2, 3, 4. -4 pi, 4 pi, maybe you do 2 pi, -2 pi here. This is sine. Sine starts at 0, up, midline, down, midline. They're all the same. Just got to get the labels right, and you got to know where to start. Sine starts at 0. The sine of 0 is 0, so sine starts at 0. We got to talk about one other concept. Everybody got it? What about reflecting over the x-axis? In other words, multiplying the outside of the function by a negative. That reflects over the x-axis. So that's the last thing we'll deal with, actually. We'll take care of the 2 by going 2 up, 2 down. So the 2 is taken care of. We can take care of the 3 by taking the period, 2 pi, dividing by 3. Well, there's not much to do there. Just the 4th mark, 1, 2, 3, 4. The 4th mark is 2 pi over 3. 1, 2, 3, 4. 2 pi over 3. What's halfway? What would I make the halfway mark? It's not a trick question. It's half of 2. Pi over 3, right? 1 pi over 3. So this is pi over 3. This would be pi over 6. Half of that. Half of pi over 3 is pi over 6. Then we just count by 6. 1, 6, 2, 6, 3, 6. 3, 6 is pi over 2. Now that'll be important eventually, being able to label all 4 of those. Right now, not a huge deal, but I know what's in your future. I know what's down the road. It'll be important to be able to label all 4 of those. I'm not telling you it's difficult, but make sure you can do it. This is pi over 6. 1, 6, 2, 6. 3, 6 would be pi over 2. Now we took care of the 3, we took care of the 2, we took care of the 3 with the 4th marks. Whoops, those are all negatives. Now we have to deal with the negative, the fact that we're reflecting over the x-axis. Sine starts at 0, and it would go up to the highest point, but we're going to start at 0 now and go down to the lowest point because now we've reflected this over the x-axis. So this sine graph from 0 to the right goes down instead of going up. Now this goes up, midline, down, midline. There we go. Any questions? Awesome.